Okay, so all around us, like right this very second, there's this secret world buzzing with activity. It's a kind of social life where tiny little particles are constantly meeting up, mixing, and changing into new things. And yeah, we're talking about the world of chemical reactions.
And look, this isn't just stuff that happens in a high-tech lab. I mean, it's the real secret behind why an old iron gate gets all rusty, or why a campfire feels so warm. It's even what's powering your own body as you're listening to this. So, what connects all these things? You guessed it, it's all about chemistry.
So, at its very heart, it's all about transformation. A chemical reaction is basically just a process where the things you start with, we call those reactants, get totally rearranged and turn into brand new substances, which we call products. And this is key. It's not just like mixing salt and pepper. It's a real fundamental change. Okay, so how do you even know when one of these transformations is actually happening? Well, you've got to look for the clues. There are some classic signs. Maybe you see a sudden change in color, like when silver gets that dark tarnish. Or maybe you see bubbles of gas fizzing up. Or you might touch the container and realize, whoa, it's gotten really hot or even super cold. And sometimes a solid just seems to magically appear out of a perfectly clear liquid. All of these are little signs that a chemical party is in full swing.
You know what? To make this all easier to wrap our heads around, let's think about it like this. Imagine the entire world of chemistry is just one massive, nonstop party. The elements and compounds, they're the guests. And the chemical reactions, well, those are just all the different ways they interact with each other on the dance floor. All right, so if it's a party, what are the most basic things that happen? Well, it really just comes down to guests either pairing up or, deciding to break up and go their separate ways. It's all about making and breaking bonds. So you've got two of the simplest moves at this party. First, there's combination. That's where two separate guests, let's call them A and B, hit it off and form a new couple, AB. Then you've got the total opposite, decomposition. That's when a couple, AB, decides it's just not working out and splits back into A and B.
Let's zoom in on combination for a second. Imagine calcium oxide meets water at the party. They start talking, they interact, they form a bond, and bam, they become one single new thing, calcium hydroxide. So two things become one. Super simple, a new connection is made. And then, of course, there's decomposition, the big party breakup. It happens. You take a single compound, like calcium carbonate, you give it a little nudge, maybe you turn up the heat, and it decides to split into simpler things. In this case, it breaks down into calcium oxide and carbon dioxide. So one thing splits into two or more. Okay, but let's be real. Party drama is usually way more complicated than that, right? Things can get a little messy. And that brings us to the great switcheroo. This is when the guests start swapping partners. So first up, we've got something called simple displacement. Picture it. Guest B and guest C are dancing, they're a couple. But then along comes guest A. And guest A is a bit more, let's say, popular or reactive. A just cuts right in, kicks B to the curb, and forms a new couple with C. And poor B is left all alone. It's a classic power move, where a more powerful element just displaces a weaker one. But that's the big question, isn't it? How do we know who gets to cut in? In the world of chemistry, how can we tell which element is more popular and has the power to just kick another one out? Is there like a VIP list for this party?
Well, yes, there absolutely is. This right here is the cheat code. It's called the reactivity series, and it's basically the ultimate power ranking for all the elements. The guys at the top, like potassium, total party animals, super reactive. The ones way down at the bottom, like gold, they're kind of the quiet wallflowers. And get this, there's an awesome little mnemonic to help remember the order. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. How great is that?
All right, let's see how this works in the real world. If you look at the list, you'll see zinc is higher up than copper. That means it's more reactive. So if zinc strolls up to copper sulfate, it's got the chemical muscle to just kick copper right out and take its sulfate partner for itself. The more reactive element, it wins, every time. But what happens if two couples run into each other? Well, that's when you get a double displacement. This is just like two couples on the dance floor locking eyes and deciding, hey, let's switch. A was with B, C was with D. They do a little doocy-doo, and suddenly A is with D and C is with B. Everybody gets a new partner, and boom, two totally new couples or compounds are formed. Okay, so we've talked about all the social drama, the hookups, the breakups, the partner swapping. But every party has a vibe, right? An energy. And in chemistry, that vibe is all about heat. Do these reactions give off energy and heat up the room, or do they soak it up and make things chilly? It really just boils down to two main types. You've got your exothermic reactions. These guys release heat, making everything around them feel hotter. Just think exo for exit. Heat is exiting the reaction. And then you've got endothermic reactions. They do the opposite. They absorb heat, making everything feel colder. Think endo for enter. Heat is entering the reaction. Exothermic reactions are definitely the life of the party. They're the ones giving off all the energy. That incredible warmth you feel from a bonfire, totally an exothermic reaction. And get this, so is respiration. The process your body is using right now to get energy from your last meal, that's literally an exothermic reaction, releasing energy to power everything you do. Endothermic reactions, on the other hand, are kind of like the chill-out crew. They need to pull energy in from their surroundings just to get going. And probably the single most important example of this on the entire planet is photosynthesis. Plants are literally absorbing energy from the sun to make their food, pulling that energy and heat right out of the environment. So let's recap. We've seen couples getting together, breaking up, swapping partners, and totally changing the energy of the room. But why does any of this matter? Why should you care about this crazy chemical party? Well, because these few simple rules, they're running basically everything in our world. And this is where it gets really cool, because it connects directly to you. The energy you're using just to process this information right now, exothermic reaction. The food that gave you that energy, it grew because of an endothermic reaction. That rust you saw on a bike the other day, that's a combination reaction. The process of getting pure metals for our phones and cars, that involves decomposition and displacement. And that antacid you might take for heartburn, that's a double displacement reaction, my friend, neutralizing the acid in your stomach. See, it's all connected. So it turns out the secret social life of chemicals isn't really that secret. It's just a set of surprisingly simple and predictable rules. You've got your combinations, your decompositions, and your big switcheroos, all driven by energy. And these few simple rules are responsible for building our entire world, from our own bodies to the planet itself. Which leaves us with one big question. Now that we know the rules of the party, what are we going to build with them next?